kick us off.
Okay, I guess we're ready to start. So this is the large mission scale working group meeting at ESIP. And I wanted to give a few introductory slides, although I thought we would make the session mostly interactive. And what motivates this is, how do I change this? Which arrow? But I did that. Just click on the slides.
Yes, we're in the wrong window, yes.
Okay.
You can just use this.
Yeah, we're in.
I knew where the cursor was. What do I do?
Click the use slide.
Okay, you got to remember, I'm standing like 10 feet above this.
Oh, okay.
Okay, good. All right.
And let me just minimize.
And I want to speak to just a bit about what the motivation for having such a working group is. Yeah, I don't know how you did that. This started with some experience that we had at NCSA, where we had a climate scientist that was fusing all the data from the historical record of the Terra satellites and ended up producing a 2.4 petabyte data set. And it came with, it was a prior access grant from NASA, and it came with a story about the difficulty of acquiring all that data. And he did the work at NCSA on basically computing that was awarded according to merit. This person's journey, becoming a big data scientist by building such a data set, and his problems were an interesting use case for us at NCSA. At NCSA, we also have seen a non-Illinois Earth scientist in a project called Arctic DEM, making a large polar map, large fine-grained polar map of elevations in the Arctic, and is proceeding on to investigate doing the whole world, not for a NASA project, but for the Geospatial Agency. And then also that we noticed that the large-scale data use is not limited to NASA-hosted data sets. So, for example, my climate scientist would like to get other data sets that don't originate from NASA, do further work, and combine them with his fused data set for Terra. So that it always seems to us that there's always this business of moving data sets, hosting data sets, and some of which will be borne by experiments. The question is, what difficulties are related to these sorts of scale items? Right? All other items are Chris Lynn's working group. We're looking for things that are related to capacity, using multiple sites, transferring data, problems in software infrastructures that these people rely on to support their work. So the general charge from the SWOT diagram for the working group is to go find pain. And where would we find pain? Well, people that are trying to get science done is one topic, right? I would say that we're interested in earth science in general and not limited to the currently funded NASA investigators, since the problem is probably generic to large data sets in earth science. So one aspect is, what are the limitations for people that want to do proposals but felt that they couldn't do it because of technical difficulties or even technical impossibilities? Is there a demand out there to get research done where the research is never proposed due to perceived problems in actually executing a research project? The other aspect that we're interested in is people who supply data, like DACs. Right? What requests are they seeing, and are they having a difficult time to satisfy the request for large data sets? Or more in general, right? Is there a gap or need for large-scale infrastructure, including connectivity and including middleware and software, to iterate over these data sets and process them? To reach a scientific conclusion. The activities that we want to support is to get a sense of the impact of scale-related problems by actually collecting use cases or stories or anything that either one of these classes of people would be willing to show or tell us from the point of view of a data supplier, from the point of view of a person trying to exploit large data sets. And then we also are trying to identify solutions from any domain, NASA or outside NASA, that might be useful. So our plan for this session is that we're interested right now in trying to understand more about what is out there in the world and what issues are there, right? So as the slides say, are there people here with investigations that are challenging due to the size or capacity needed to do their work? Are there people here with a novel solution that are doing work that would have been considered challenging by others? Is there anybody here with proposals that they've never made because they thought they would just be not allowed because they're not feasible? And is there anybody here with stories about stress placed on software or infrastructure due to large data requests? And so Ben, my colleague, is going to try to facilitate a kind of interactive session where we try to probe these issues and have a discussion about these issues or anything else that seems relevant to the group.
So we have one person dialed in, but I think.
Hello.
Hello.
Oh, I just want to make sure that you can hear me. This is Matthias.
Oh, hi. I'm just thinking with a intimate group, trying to like pass microphones around and do everything. Yeah, I think, yeah, I'll say it. I think we're gonna get intimate in the room and probably have a lot of discussion out here. So I'm not sure how much will be picked up by the microphone, but I don't wanna. Yeah, we'll see. Okay, we'll try. We'll try roving mic. So now I'm gonna do my Oprah Winfrey impression or something. What was it? So yeah, so we're trying to get our arms around what this problem and like what are the problems that are out there. I'm very new to this space, and so I can ask all the dumb questions. And I like to start by putting everyone on the spot here and just introduce yourself, like why you're here, if there's some things that you that brought you to this or what you bring to this, and just to break the ice and get our conversation going. I'm looking at you because I'm gonna start with you.
Sure. Hi, everybody. My name is Lee. I'm the information manager for the SBC OTR, which is stand for Santa Barbara Coastal Long-Term Ecological Research Group. And so as an information manager, I was looking at the data that's outside our own scope, and also every of our researcher, when they need to access data outside of our SBC group, Santa Barbara Coastal Group, they always come to talk to me, say, okay, we want sea surface temperature because they're doing marine research, and we want the whole continental rainfall. We want the rainfall data from this watershed that along our Santa Barbara coastal area, and we also want if there's a algae chlorophyll that from the satellite data, we want that. And if any of the satellite data can see the kelp canopy on the ocean, we like to have that. And so I've been going through many different agencies to look for a variety of data. And when I see the title of multi-platform, my sense was, is there a software? Is there something can easy access those? Can just pull down some drop-down menu, something that I can use? So I also have a whole bunch of coding that help myself to pull those data out from the online API. But that's not a long-term process because all these links have been updated every year, and there's always a broken link happening on the NASA website too. And it was like, okay, let's see this experts here. I'm looking for some more novel technology here. Yeah.
So are the issues that you experience more the number of data sources, or is it the size of the data set? Are they relatively modest data sets, but just a lot of them?
I think my particular purpose, first, they locate on the multiple spot. Sometimes they have the same copy, but they have different names. I don't know until I dig into it. And sometimes on the surface, when I try to explore, let's say ERDAB, that posting a whole bunch of data set, it's hard for me to tell from the actual metadata they collect, to dig into it, to know the actual range. And also, funny enough, even the same data set in the ERDAB, when I pull in the same long and lag, they actually pop out totally different location because they have a totally different way of document that. So I was like, is there any some consistent? Because when I want to download sea surface temperature, when I want to download the chlorophyll, I wish when I put in the one set of long and lat, they should pop out the same location, but they don't. And so that'll be like, okay, this is something must be better than I personally go through one by one. Yeah.
But they're not large data sets by the time. Okay. Okay, but that's the complexity. Hi. We'll come back to you. I'll let you get some context. So we have so yeah, there's the plan. We'll come back to you.
Hi, I'm Brian Nosp from the Jet Propulsion Laboratory, and I'm the data manager for the MLS project, which is one of the 4 instruments on the NASA Aura satellite. So I deal with making sure our data users get access to our data, that our science team gets access to our data, and also managing a lot of the validation sets that the science team uses for comparing it to MLS data and things like that. So we use a lot of other data sets with MLS, a lot of NASA data sets, satellite data sets, model data sets, some non-NASA data sets as well, but those are probably fewer. And the biggest problem we're having recently is not in terms of storage or access to the data. It's in actually using APIs and other tools to get the data, because it's even subsetting it's too large to download, or B, the APIs are so ill-defined and buggy that we can't actually get them. I've been working on downloading a bunch of ERA 5 model data from the ECMWF's CDS data system, and their API for the type of data that we wanted was not very well formed, and the download speed was slow, and also they had a bug in their code which they said was a known problem, where the script would fail that I was using, and their solution was to go use the URL and download it directly through the browser, which was not the response or solution that I wanted, and things like that we encounter at the MLS Science Computing Facility. I also work on a few other missions too, like OCO2, OCO3, errors, and those missions too. More on using those data sets too with different types of services and visualization systems to let the folks see what's going on with the data, how they compare to other data sets and things. So I came to this to see kind of what other people were doing and what other solutions there were for getting access to these larger data sets.
I'm Ann Wilson. I'm from the Laboratory for Atmospheric and Space Physics, and we do research in space. And of course, we have large data sets around that. And we have a project funded by NASA to build a platform to manage hyperspectral imagery in the cloud, so that people can subset and to some set aggregate and interpolate and resample and that kind of thing. And I guess at this point we'll take the opportunity to make a comment that my experience has been that scientists will ask for lots and lots and lots because they just do, and that's how they think. And so like I wonder about your person who aggregated all those data sets into that multi-petabyte file, like what they actually gained by doing that. And so just an observation that in my opinion, this is a tangent to the problem. There's a real problem around this, but some sort of training and education on the scientist end would be useful.
Hi, I'm Steve Alding. I'm the sort of project coordinator for the Earth Science Data Systems Working Groups. This is one of the working groups I look after. And I don't have any big data sets of my own.
Hi, I'm Amanda Leone. I'm the NASA DAC manager at the National Snow and Ice Data Center. So I am responsible for helping to get big data in the hands of users. NSIDC has a lot of kind of complexity in our data, but it's only been recently we're hitting kind of large volume missions. We do have time series that go back 20, 30 years, which can sometimes provide kind of large scale problems. But with some of our current missions, the volumes are getting bigger. And we've been taking approaches of trying to provide services that help users reduce the volume that they're trying to move around, like Anne was mentioning, so subsetting. But we still see there's applications that simply want all of the data in its lowest level, biggest format. And that could be everything from like Google Earth Engine wanting to suck in all of a Modus product, or just different applications that want a copy of that low level big data set. So I'm here just to see, obviously there's lots of discussions about bringing the processing to the data in the cloud. That's one way to approach this, but I'm interested to see if there's any other discussions about how we tackle this problem besides just expecting processing to move to the data.
Hi, I'm Ziheng Sun from George Mason, and my focus is on deep learning on the remote sensing data to extract their crop information. So we have, I'm using multiple terabytes or even tens terabytes data downloaded from NASA and USGS. And we're also using the data from USDA for validation. And we have data collected from the field, the drone data, and also in-field measurements from our experiences. So we have multiple, we have a lot of data with different formats, and all these heterogeneous data set are big in some kind of sense, because several terabytes for me is because I have to analyze using the deep learning model, which is causing a lot of resources. And if you are training the models on a terabytes of data, and if in traditional way, it might take weeks or months. So so the problem I focus on is not only the volume, it's also about the velocity. So I want to hear about some suggestions from this working group, and we can discuss about possible solutions.
I'm Chong Xie. I'm a career research scientist for more than 30 years. And I was a major PI and producing large-scale data. And 6 years ago, I've been recruited to the DAC, Justice, as a project scientist. I'm still trying to find a niche to be a hybrid scientist, transform from research to data scientist. So anyway, I'm here just be curiosity and see if anything I can contribute with my knowledge, and also same time I will learn from you guys. Thank you.
Yeah, so my one of my day jobs at NCSA is to help support Larry Di Girolamo. It takes a while to get that going. He is a climate scientist, and so he's interested in the climate record. And so he is interested in accessing the whole record of the Terra satellite, which has 5 instruments on it and has been producing data relevant to climate scientists, let's put it that way, from 2000 to 2015. In the previous round of access grants, he got a grant to facilitate the processing of all that data. And I understand his problem roughly as while the Terra satellite was launched, there was a promise that all the data from all the instruments would be easily accessed across all the instruments. In fact, budgets in reality were such that the people running the instruments looked down into their instruments and had to spend a lot of time getting the calibrations and getting the fundamental data just right. His story is that he had students trying to unite these data sets to produce climate-related science. And they spent every time that he sent someone down there, it took them a long time to go figure out how to relate the data sets to each other. So his access proposal was simply to say, I will take the record from all 5 of the Terra instruments. I will bring it to NCSA, where he had awarded free awarded, computing that was awarded on intellectual merit. And I will build a fused data set where now all of a sudden it will become easy to access all the data from all the instruments across a point in time. And because he's a climate scientist, the data set would be optimized to kind of stream through all 15 years and produce insights about the climate over a 15-year period of time. In practice, what this involved was taking 1.1 petabyte input data sets. This is the record of all the instruments from 2000 to 2015, and producing a kind of easy to use fused record. And so while the input is 1.1, the easy to use version is 2.4 petabytes of output. And he's produced this, and the idea is that people will stream through this, including him and his students and people interested in clouds, and look at all this data and produce knowledge. Our current state is that he's been able to enjoy use of this data set on an HPC computer that NCSA has. The current project is to take this data and put it into the cloud, where a data set of this size we're working with NASA and taking step by step and learning how. But we expect to have this data set ingested in Amazon East end of September, I'd say. All right, so it's 80,000 files, it's 2.4 petabytes. We move thousands of files a week, but it will take some time to get it all up there. And so his pinch points and pain points were actually, number one, I would say downloading all that data from the DACs and getting it. And so this is a process that maybe very naively thought would happen fast, but in practice it took him a year, maybe perhaps a little bit more than a year, to integrate these data sets and storage at NCSA. And then of course there's the time it takes to learn how to fuse the data properly. While the fusion computations are not large, but of course this is making time all the same, right? Relating the pixels of one scale to another scale and so on and so forth. And so his story is about the trouble of getting the data out of the data access centers at that scale, right? Give me everything is different than give me, here are some well-defined regions of interest, give me this. One's a retail problem, one's a wholesale problem. A second problem now is now that he's produced this thing, dealing with NASA to ingest this into the cloud environment, where this is of a scale that it's very novel for NASA.
Lost your exact phrasing, but you said he had challenges getting it out of the DACs at that scale. Could you be more specific? Like, was it the transfer rates? Was it, like, what about getting it out was were the pain points? I'm assuming there are many.
I was not around when pain was incurring, but I believe it was fundamentally the transfer rates, that there were secondary issues. When you deal with that amount of data, there's always a certain amount of corruption. There's always a certain amount of, oh, that file wasn't what we thought it was. My impression is that was a minor component of the problem, that it was fundamentally about transfer and time to acquire these data sets, which took over a year, because I think it was a surprising request to the DAC infrastructure at the time. So he is very interested in mission scale stuff, because climate scientists, I guess the gold standard in climate is 30-year baseline, and the 15 years of Terra is approximately that.
So he's putting this this data set that he's created into Amazon Web Services, right? Is that for just general use for anybody who wants to use it? Well, well, follow on to that, to your answer. If that's the case, which you've given me the thumbs up for those on the phone. So I mean, I've heard a lot about how the NASA DACs are moving a lot of data to the cloud, but my understanding of the AWS model is that somebody has to pay for data ingress and egress. So how, as a user, would I need to pay for that to use it maybe quickly in the cloud versus, it might take me more time to get it from the DAC, but it's free?
So I have a newbie's understanding of NASA, probably not as well as yours. The current ingest project is not run under the auspices of any DAC. It's run under Raoul's impact program. It's my understanding. Okay, so
So I'm DAC manager involved in the development of yeah. So NASA, specifically ESDIS, who Steve works for, is developing an AWS-based ingest and archival system, which will store data in the cloud. It's not under Impact. Raul's doing a bunch of cloud stuff with Impact, but Cumulus, and there's talks about it, is ESDIS. So it's, you know, a lot of data, it's still kind of being phased what data will move into AWS as storage at this point, but like some of the new missions will be going into AWS. To your point about egress, yeah, there's egress costs. The position is that NASA will continue to support free and open data, and so if you egress data out of AWS, the user does not pay that cost. However, if you want to bring your processing into an AWS environment and work alongside the data, then just like now, NASA or ESDIS project doesn't pay if you want to run a supercomputer somewhere. That would be on the user to pay for the processing.
okay, I don't need that now.
Oh, yeah.
Yes. So I believe all that, but what I've been told is this is a special one of, this data set is a special one of, do you know of this data set?
I have heard of this project to
Okay.
create this data set, but this data set's not managed within EOSDIS. So it doesn't fall under the purview of,
yeah. So
I mean, at some point, if NASA headquarters assigns it to a DAC
yes.
for management, and hasn't been assigned to
So that is my
ASDC.
understanding, is has not been assigned to
Okay,
a DAC as
yeah.
of yet. But
Yeah.
you know, you can talk to three people and get different answers because NASA's a large organization. That's the way large organizations
I
are.
can't speak to that, but data, what Cumulus is for is management of data that's within the EOSDIS program and managed by DACs. And
Yeah, so my understanding is this particular data set, right? So the plan that has been described to me by the people I'm liaisoning with, but you know, they're not the big politicians and the decision makers. These are some soldiers working on this stuff in Huntsville.
yeah,
Is that the first goal was simply to ingest it because NASA promised to take it. I think the size of it pushed the processes of NASA, and so this is in some kind of exception box.
mm-hmm.
Their plan, as articulated to me, was that they will allow public access to this, but somebody will have to apply and they will supply keys.
Mm-hmm.
That it's so large they don't, you know, this is a daunting experiment. So we're on the bleeding edge, and the particular mode of storage is that it will be an S3 bucket in Virginia, and that like I said, you'll have to apply to get a key. They'll give the key out freely, but they want to control access, and they're storing it in S3 and frequent access.
Yeah, I can't speak to edge cases. I just kind of know the standard.
So this data set is an
direction.
edge case.
Yeah.
And the wheelhouse is to spin through the whole thing and learn things about climate, but there has been interest in it because of the work that was done to relate one instrument to another, where I don't understand that very deeply at all.
So since I have the mic, this raises one question that I often think about as a DAC. I mean, we can move data AWS, but how, like, what's the adoption rate of the user community to actually move their processing there? Or will the users of this data set be faced with the same problem that this PI was faced with? Now they have to, they need to transfer down this giant petabyte data set in order to work with it. So we still have the problem.
So we are looking, so now that we have the ingest running like a well-oiled machine, right? Just we got batch jobs and we're pushing it up there and it's going fast and all that kind of stuff. I see our next goal is to assist Larry in writing a paper for how to exploit this data. And one of the things I would like to fish for here is an example. So presumably we ought to try to use it in Amazon and say at least this much worked for us. You know, you get this big of a machine, it comes this fast. Here's a way to iterate over it. Here is a place to put your derived data products. And we are not under the Cumulus umbrella. right now, but we think that part of letting the world have a crack at this is to at least give them some guidance about how to exploit it in AWS, because that's the direction NASA has. And I do not think that NASA wants to pay multiple people to export petabytes and petabytes of data, right? So our current struggle is to figure out what is a reasonable way of collaborating with NASA that we can give some guidance that might help push the cart down the road.
Yeah, I'm kind of just change a little bit from the scientist point of view, okay? Because like I mentioned earlier, I'm a data provider. So first thing came to me, okay, is the data integrity. So I'm not sure, is this already still an issue for the transferring, because you're so, because I remember when I was doing a PhD for when I do the supercomputer, every time I change to even to the other note, my advisor says, hey, you need to make sure everything okay, teach bit by bit, so the same. So
our integrity checking program.
You do have that, right?
Yeah,
okay.
is the project recorded birth SHA-256 CRCs when the data were made. And we've actually had to take it off tape through a couple hops at NCSA before we send it to you guys. We have a project, part of our workflow is to check the SHA-256 when it gets on the transfer node on our side to make sure that nothing was lost.
Sure.
In all those hops, like you mentioned, because it happens, right? But and then we're uploading it and doing the AWS SHA-256, and the issue is, of course, the packaging of our files, since the data set is large, is how a scientist would first think of it, which is all the data in an orbit. And all the data in orbit is about 32 gigs on the average. And as we are all aware, of course, Amazon, if your objects are bigger than 5 gig, turn them into segments of some kind. And Amazon does not provide the SHA-256 across the whole 32 gig. They check it per segment and build some sort of digest on that. So one thing that I want to do when we're done is SHA-256 the whole thing as it lands and compare them to the birth SHA-256s. And that will be our integrity program.
Right,
I don't know what you think of it. I think that's adequate, but if anybody wants to comment on that, that's fine.
Right, okay, thank you. So you ever experience, you do see some flaw occur during this transfer?
I'm sorry, did we?
When you do check, right? Have you ever experienced, you did find some glitches you've done?
Embarrassingly enough, the one glitch we find was a production imperfection where they were touching up the data set and adding a few more annotations. And for a little bit of it, we got the previous version, but the next SHA. So we found a production accident. I don't do this work. I have people that do this work for me, and they have not come back to me and said I found anything.
Okay, good.
But I couldn't swear. I couldn't swear that we have no corruption.
I just want to bring in our new contestants. You got a sense of what we're about here?
Jason Gallo, I'm from the Science and Technology Policy Institute, which is in Washington, D.C., and I do the policy part, and so I'm here out of curiosity. But for 9 of the last 11 years I've been at the job, I've worked with the U.S. Group on Earth Observations, which is an interagency subcommittee that deals with a number of things dealing with Earth observation. One of the working groups under that is a data management working group. And so for a number of years, sort of under the mantra of making Earth observation data more discoverable, accessible, and usable, from a policy perspective, easy to write down from an actual practical perspective. And this conversation about AWS and then looking at what major agencies are doing, NASA, NOAA, and USGS primarily with moving to the cloud. How do you put services adjacent to the data? Those are the types of things that we're doing some thinking of. And so I'm here to really just to listen and hear more about that, because when we go back and write these things down in papers or policies or agency recommendations, where the rubber meets the road is actually where this is going to happen. So I'm very curious to hear the conversation.
Hi, my name is Anna Myelin, and I don't work at a DAC. I actually don't even touch any data. I am a metadata person, and I work at NOAA. But I care about this because we're working on making all of those millions of granules associated with this big data sets available and discoverable at a very granular level. So with the one-stop system that I'm a member of the project, we are making decisions about how to make all of those granules discoverable through standard metadata, maybe non-standard metadata. So now we have millions of files of data that we're also moving around, but we have millions of files of metadata to represent each data. And so that's our interesting problem.
It just seemed like you have similar interests because it seemed like your problem is so much more metadata. Oh, great.
Is it the same? Is it the same data from the Terra satellite that she was talking about?
Could you repeat?
Is it the same data from the Terra satellite that she was talking about?
We're not working on Terra satellite data at NOAA, I don't think, at least not in our archive, no. We have GOES data, we have NPOS data, those are the biggest ones. And we have lots of variety. We have large volume sea observations and data that comes off of ships, multi-beam, water column, passive acoustic, and then a whole bunch of variety of little data sets as well, which if you put them all together, they look like one giant, big, messy data set.
Thank you.
That reminds me, you have two people dialed in. Why don't you introduce yourselves and see if you have what you can bring to this?
Can you hear me?
Oh,
yes.
Oh, I see. Yes, that's
okay.
Matthias. Yes.
So yes, I'm also from NCSA. I'm also involved on this Terra data that's going on, and I just wanted to say a comment about the moving the data from tape or from disk to AWS. One of the issues that we need to think, and other people need to think about before moving the data into the cloud is how how you're gonna make this data discovered, first of all, and somebody was talking about the metadata, which is critical in this stage, and also how big or how small you want to make those chunks of the data for people to access. And the reason is, for example, for this Terra Fusion data, where we fuse all of the instrument in an orbit, making one big file of 30 gigabytes. If there's a scientific case where people only need, for example, a portion of the data, say one instrument or one channel or one particular small portion of the data of the orbit, say one location, once the data is on S3 buckets, you need to stage the whole file just to access a few megabytes of data, but you need to move the whole 30 gigabyte file, which is obviously not convenient for people who's paying for the egress, or even if you need to wait for all the transfers to be done. So that's something that is definitely critical and needs to be included, way before, even before, start moving the data. It has to be on your plan, because once you chunk the data, then another question comes to play on how you're gonna, make data discoverable, or how you're gonna put a metadata server on top of that data, so you can get to the right bucket for the right chunk. I mean, that's what I'm trying to say. It's how you chunk the data, how granular you want to make the data, and obviously you can keep a small amount of files, but then the egress gets complicated, or you can keep a large amount of files, but the bookkeeping gets complicated, but the egress is easier. Just a comment.
Okay, thanks. So one of the questions that we had up here that I wonder about is, how much does anyone have a sense that scientists are self-censoring projects like this? Or are they mostly asking for things and then discovering how hard it's going to be? Have you had experience where you think scientists are not proposing projects that involve this much data because they just know it's going to be painful, or what?
I haven't encountered that. Usually they just kind of know it's going to be tough to get the data and then bite the bullet and go for it. I mean, funding's funding, right? I mean,
we were wondering whether the funding agencies might, if they see a proposal that's too ambitious, that they might say, "Ooh, do you know what you're doing here? That this is the next year of your life, just getting the data."
I don't know. I think they're the ones making these huge data sets, right? Usually the funding agency like NASA is, responsible for SWOT data, which is gigantic. So they know what the challenges are. So, I mean, they would judge if the plan is realistic or not.
So are there, anyone else have any thoughts on that? Is that, because I know like you're working with machine learning, which do you ever think, okay, I don't know if I want to propose this developing this model because the data is going to be too hard to get to?
I think it's very difficult to actually get some model to run operationally, just like data services, and we are producing value-added products, which is derived from all these observations. So hosting the original observation is one thing, but about all those derived products, it might end a couple of times of the data volume, and so take our use case as an example. We are working on the crop mapping. So right now the crop maps only has one product a year. So that's one layer a year. And if we are using deep learning, it's going to be like one layer every 2 weeks. So and I don't know if NASA can fund that, but because that hosting service will absolutely take a lot of resources, and it might be not doable according to the funders' perspective. So if I want to propose something like this, I'm gonna be very careful about how to host that data, but just to tell them this model can work, and the product has very high accuracy, and if people want to use this bi-weekly product, we have to work with NASA, with Amazon for to contribute more effort on that.
Can I have some sharing here? We know we are all this big data era here, and also at this time we really don't worry about the storage. People, even when 10 years ago, 20 years ago, you probably don't, in entire world probably don't have too much petabyte data. But now even you personal computer you can have that. So, but as a data producer myself, I'm thinking we can you're asking, is that possible? The proposal was not funded just because of the data issue. I don't have that kind of experience before, right? So, but only when I try to do a measure second, they complain, okay, I didn't write the first paper too much. Okay, that's the main reason, right? Anyway, but my concern is that we kind of increasing, especially now we don't have any limit for the storage. So we keep on producing data and data. So I wonder at the same time, we probably need to think about this. How we are going to also retire the data. Of course, it's not retiring the legacy data, not retiring the historical data, but just kind of version 1, version 2, version 3. So I think at the same time, we probably also, even we know that now technology can easily, even like see the Amazon, they can download. For me, okay, probably okay, at the time, we even can now afford just to have more than 1 terabyte data there. So perhaps, I'm not sure that scale data, probably this is not our objective here, but I'm just trying to share what am I thinking. Okay, so not only we are how to deal with the big data, but same time we probably don't, just like we don't want to produce garbage too much, right? So even though we want to go green, we can handle all these kind of things, but at the same time, how can we optimize? How can we optimize our data community? That's, at the same time, of course, we need to. I think that's a good thing when I join the data community, because I can perform like a bridge. I keep on advocating between the research scientists and also the data scientists. So at the same time, because sometimes we can educate the research scientists. Yeah, that's why I always go back to my old colleague, and they consider myself as a traitor. Hey, what are you doing now? It's trying to come back to force us to do something else. Yeah. Anyway, I hope this is not off track.
Just along similar line, I'm both on the producer side and user side. So like think the maintenance and also the sustainability of the data is really important. I'm using different data set. I'm also using SSMI from the NSIDC, the raw data. I'm that type of person where Anne is saying that I'm always asking for too much. I want the high resolution, the original like data set, because I'm producing long-term data records. And so how we can make sure the product you're producing can be sustained through the time and when you're doing the proper maintenance. So even for the fusion data set that the people are producing at your place, that because Terra data is like keep coming in.
It keeps coming.
So yeah, your project is like from 2015, now it's almost like 2019. So you can have more than like four
more petabyte
years data. So how is the best way to make sure the project, especially for climate science, that they want longer time, the longer the better. So we cannot just stop at 15 years. They usually want like 30 years data for climate science studies.
Yeah,
so.
there's this other dimension to this, is that when you can look at the data from all the instruments, you begin to notice calibration differences.
Yeah.
And then you wonder if the calibrations could be improved.
With long-term data records and from multiple platforms.
Yes.
And then, yeah.
Right.
Definitely we need a long data. That's no question about it.
That's the purpose of the mergers. Like you just want to have a long-term records.
So I summarize in my, I'm old. I take paper notes. Data lifecycle, data lifecycle, data lifecycle. That's what I heard from the last three commentators and the issues that brings up. And the person from the DAC I most admire, your DAC, is because I always look at your ice forecast.
That's we're hurting our feeling. I'm not going to
well, you could win my heart over, but
stay in Las Vegas.
you know, I love your website. And yeah.
Oh, there we go.
Yeah, we're all fans, just so you know. Yeah, so part of largeness is concern, as all of a sudden you become very aware of the life cycle of all this data and the need to retire it, the need to support multiple versions, and the resource management and obtaining resources to do this. But I keep on telling Larry he really needed he's a 10 petabyte project, never mind his 3.4 petabytes of input and output, because there's a next version. Okay.
And that life cycle is something that we as DACs and ESDIS are thinking about when we're looking at what does a cloud storage architecture look like, because the cloud is great for access and you can do long-term storage, you can glacier, you can snowball, you can do all kinds of snowy things that we like those terms, but does it make sense to have all of these versions, old data, level 0 data, just the different nature of data that we as data archives have? Does that really make sense to be in the cloud, or do we need different architectures? So
has anybody here dealt with like virtual data techniques? In a fusion project, it's easy to notice we should think about this, because the cost to refuse the data on the fly, if you had the originals all normalized and groomed, is small. because the Fuse data products are, at some level in the world's most advanced relational database, it could have cooked up the fused version of it by doing all the mappings.
Yeah.
Is that a concept in any of, for anybody else, when you think of lifecycle management, do you think of rerunning the computations to give the user the data instead of storing the data to give it to the users?
Yes, and there's some DACs that do on-demand processing of data rather than having it pre-generated and sitting there in storage. That's also often looked at as a data recovery technique too. So if you preserve the raw, in theory, you can on-demand or regenerate. I don't know if you...
Yeah, I can share with that. Okay, actually, I think Amanda also involved with that when Chris learners the data virtual collection. Yeah, right. And also, actually, when I joined the DAC over there, I came up with an idea called a data bundle. Because I'm a scientist, right? I did the hurricane study before, so I know when I study hurricane, what kind of data I need: precipitation, wind field, temperature, all this. But when I go to DAC, I even don't know where they stand, where this whole data. That just like I always like to give an example. Like when I go to Costco, I want to Home Depot, right? I'm an amateur. I just want to rebuild my kitchen. So where can I find a wall player, nail, whatever. So I came with this one. So if that's also like virtual. We can't have we develop into called data list, like a playlist. So you don't regenerate the data. You can't just hit the link. Then the people can go, the user can easily. So I call this we can provide some efficient service, which user can quickly and properly get the data they want. Yeah, just like you go to the Home Depot, you have some the window share there. Okay, they say you want to go to your house. Okay, you come to this one, the booth here, so you can get things out. Of course, if you're a handyman, you know where you go. Okay, quickly. So that's a novice users and experienced user difference there. So that's kind of the virtual idea. Just to say we don't want to pre-generate those data. To kind of increase the storage again. So kind of just give you a bunch of a list of link. You go in there and now we even can provide the subsetting. And we ought to be able to do a subsetting even to the granular levels, to variables, because we have usually to subset to a collection level. But now you can go to the first, like I say, precipitation, wind field, even the for the ozone and ozone of the radiance or something like
that. I think for the virtual, I think it's it really depends on the users who want to what they want to say, because I think the point is already proved in the Google's engine, which is actually using some technique that is not processing the real whole data set. It's using some pyramid structure to reduce the calculation into very small amount. So actually, it's not all the images that you see on the map is not produced by the entire data set. It's just a small. It's in a small scale of the whole data set. So that's why it's very fast. So like 2 seconds, you get an overview of the results. But if you want to export that results, it will take about a week, right? So it's like a fake solution, but it works for most of the users. So so I think it really depends on what the user want to say. If they just want to see an overview, then such solution will give them very quick response. But if they want to download the whole data set, then it will take a week. so I think we can learn about from that mechanism.
So one of our questions here is about stress placed on the DACs and infrastructure. Are there things that you would want us to know about what these things are doing to your infrastructures?
Yeah, there's sometimes stress. I mean, we try to get out ahead of it and make sure there's sufficient bandwidth. I mean, some of the stress is in the form of data process, like services acting upon the data. So we have data transformation services. People put in a request for the entire record of MODIS and they want it reformatted to GeoTIFF. So I think, cloud opportunities are good there. One of the things we struggle with is that we don't have control over the entire network pipe between us and the user. And oftentimes there could be bottlenecks outside of our control and so when transfer rate is an issue and it's being cited as it takes a long time to download from a DAC, we don't have entire control over that. And that we try to make sure we're maintaining our network, but that problem persists, which is again why I'm interested in what techniques, what technologies, what approaches might we be considering to kind of help this challenge, because for some users it won't go away when we move data to the cloud. They will egress it down and they're still transferring data. And
are you able to tell such a person where the problem is? So if you can't do something about it, you can at least explain it to them in a way that.
Yeah, I mean, sometimes, like the reality is though, to do a deep dive into a network performance issue takes a lot of resources. Often we have to pull network experts from our host organization, from NASA. They have to do some analysis to pinpoint if there's anything going on. And then if we're really going to work it with that particular user, it often involves engaging their host institutes, network administrators. So we have done deep scale coordinated network investigations when some particular heavy hitting user is having problems, but it's a lot of
in the world I come from, which is like related to high energy physics and such things. There is a standard set of toolkits which goes by perf sonar. Is this a word you've ever heard, or maybe you wouldn't have heard because you just tell the network guy to go look into it?
Yeah,
you wouldn't know at that level.
Yeah. I mean, there's NASA network guys and university network guys that are monitoring the network and have all kinds of tools in place.
Because this was kind of developed in the era of high energy physics, where we're pushing the data out to a big tree that ends up at universities but goes to labs.
Yeah.
And it is still very, very popular.
Yeah.
But
I know they use things.
Tell them, set up perf sonar and tell me what's going on.
Outside of my
okay.
expertise.
Okay.
Just to ask you, have your DAC ever experienced the user, some big user stop all their block, stop. So what all policy there, okay? Mine was not, don't take my words, but I think that probably sometimes we need to block this user temporarily, right? And tell them and say, could you try that the other time or somehow, right?
Yeah, I mean, at times it can be like a denial of service when someone is saturating your bandwidth. And so in that case, as Anne was talking about, what we do is kind of step in and try to talk with the user. What are you trying to get? Can we help you get it in a more efficient way? Do you really need all of it? In the cloud, I'm not the expert on this either, but for Cumulus and AWS, they're having to consider this for egress. And so there are circuit breakers and throttling and things that have to be put in place so that one user can't come in and kind of, because there's a cost model change now where there's a cost specific to egress. And so you can't have one user or a handful of users come in and just take over and rack up a giant bill. So they have to put different throttling mechanisms in.
So it's interesting thinking like, okay, what are some of the use cases? Because what we want to do as a working group is make sure we have a good collection of use cases that kind of probe at this problem and at least see where, where more effort is needed. And so we'll try a little magic trick here. There's like, so one use case is complicated multi-mission metadata. Oh God, there's another M in there somewhere. Mashups. Massive multi-mission mashups, which has, you heard it was here, ESIP 2019. It was first uttered. So that's an interesting use case for this working group. There's machine learning, which obviously is driving things a lot. There's the Larry model. I don't know how many other people are doing things that are Larry-like in the world. Is that something that you see requests? Is that a fairly unique situation, what Larry was working on?
Our department is like heavy on the land cover change. So they do long-term monitoring of the different land cover types. They're using the Landsat and also Sentinel data from European missions. And so like it's really expensive if they want to do that in the Amazon AWS or something, because they do the computation. Also, it's really data intensive. They need a time series analysis. So basically, they just give up the whole route, just like we're not doing that. So our department built up the whole like cluster. By our department, we have more than 50 petabytes of the storage, and then we have like 15 clusters on different for different groups and who want to use it. So in the future, when they're applying for grants, they just buy into the department cluster to replace the old facility in our department. So that's the route our department choose to do, because we're really data intensive, and the cost model on the cloud, it's just not working for, at least for this cohort of faculty. So they decided, so it's just not.
Where are you from?
University of Maryland.
Okay.
Yeah.
So there's a similar story about, universities and their contracts with cloud providers. Is that Illinois rides on the standard Internet 2 cloud contract, which has no provision for professor walks up and says he's got a 5 or 10 petabyte problem, and now they can negotiate for a discount. And it doesn't work in the grant world, because at a government institution, the guy has to reply in 2 or 3 weeks for a grant, and that's the time scale that at least the University of Illinois can't go back to a vendor and say what would be the price for this person. It's very so there is this whole question on the university side that drives us into doing provisioning at universities because of these kind of business issues on top of everything else. Is that normally, it's a business thing. And an interesting moment was that when we did an exercise with Larry to reproduce, to take a month of, it's 15 years worth of data, but a scalable unit is like a month, because you average out the variations in the data set sizes, night, day, clouds, whatever. And we did an exercise where we recomputed that on campus infrastructure. And then we recomputed it, then we did it in AWS as best we knew how, using the Illinois contract, but spot pricing, right? And we have a system that's costed at the university, fully or not, I don't quite understand. But it was substantially less expensive. And the other problem is when investigators use data and they have to maintain the products on their own account, is the storage charges can actually come up. In Larry's case, where he was integrating up all this data over a year, the storage charges would be a good fraction of the award. And he would have thrown up if he'd known this, he would have thrown up the thing saying, I can't do this. There's no money left for synapses. It's all going to infrastructure.
Yeah, the biggest group who are doing the work in our department, they do have an agreement with Google Earth Engine and Google cloud platform. So their data will be distributed through the Google Earth Engine. So it's all, I'm not sure their agreement with Google Earth Engine, but all the users who are using the data like free of charge because it's like distributed through the NGO. So I think Google Earth Engine have the agreement with NGO that the distribution of the data are free. So the user is more targeted on the local government agencies who want to monitoring their land cover like changes. So that's another the model they are choosing.
So it's spotty, right?
Yeah.
You know, the cloud is not a common carrier that is obligated to charge everybody the same price.
Yeah.
Right. There's all kinds of deal making acumen underneath all of this, right?
Yeah, I'm not clear about the AWS cost, but we have some experience because right now the university is gathering all these servers bought by the national government the funds. So they are building a very big cluster in GMU. So as far as I know that 1 petabyte is cost like $50,000 a year. So nobody's projects can afford that. But that's their price, and they also they can because that cluster is built by their office in university, so they have some kind of contract agreement with the professors. So if you contribute your servers into that cluster, then you can freely use the cluster for some amount of time. And that cluster has many GPUs and a big storage. So in exchange, you can, if you contribute your servers to that cluster, you can have the priority to use that server.
So it's a kind of condominium that you get first priority on what you bought, and then you can use the unused part of the
because the server is in the cluster, so everybody in the university can use it.
What university is this?
George Mason. Yeah. So the disk is like 1 petabyte for 1 petabyte is $50,000 a year, and we didn't agree on that. So it's like not using it anymore. So yeah, the cost is very high for universities, but we have to take advantage of these servers. It's not saying that we have AWS, we are discarding these servers. We have to still using them because all this money we invest on, we have to, combine the private resources with public cloud, and how to take advantage of both the resources to collaborate on the same task. So that's I think that's something we should think about.
So the word that's often used to describe this is hybrid computing.
Yeah.
Does that accurately describe your?
Well, actually, I have a post outside called hybrid workflow.
Okay. So then another topic that came up was life cycle. That's something that has to be considered for this working group. I think summarizing the DAC perspective, it was mostly networking. Was there that seemed to be?
In terms of trying to get data out to the users, that's kind of the biggest piece of that puzzle. Yeah, and compute. Yeah.
Of course, well, I'm not sure this is for this topic here. The data discovery is always an issue for the DAC. We try to help, even okay, well, how do we even reach to users? And we have so many. We have published so many Earth data, including my own data there, Earth science data there. So honestly speaking, okay, Google really play a very important. I think that through the Google probably is the one, okay, they find out data the most through the Google search. That's so even if we say so, during the AGU or whatever conference, even though my old colleague, just a building, I was used to be building 33, now I'm building 32. Even my neighbor building scientists, they even don't know this data is came from this stack. So they don't care. They don't care. Just whatever I got it, right? And so as long as it's free, okay, that's more important. And so they got all free lunch service so many years. They just been abusing that. Okay, I'm not saying abusing, sorry. But again, just I think how do the users can be data discover, and also because so many data there, which data is more proper, okay, useful for them. Sometimes they even cannot do, right? So we also did that because as a scientist myself, I try to tell that my colleagues say, well, probably we can even provide some kind of knowledge. We call this a value added data or whatever. But unfortunately, the other side of the science, like my used to be, right, against it. Hey, how you gonna do? And I'm a scientist. I know which data is better. Okay, it's not your job to tell. But I always, but I don't think that I don't totally agree with that. I consider the data distributor is just like a salesman for the car. And the scientist, right, is the production of the car. So even the salesman probably even know better, okay, than the data producer, okay, know which one is better. See, of course, but the data producer, they don't think so. Because they also always consider mine is the best, right? So, so anyway, yeah, that's what I'm trying to say. Yeah. So actually I know Trim's better than Mera or whatever.
Now you've got it. I want this data set. Well, wait a minute. I got to go talk to my manager.
Yeah. Yes. Right. See. So anyway, don't tell my whole the other deck. Okay. So and also don't tell my peer scientists.
Can I ask a follow-on question? Is any of this data discovery business that's clearly a headache? Is it qualitatively different for people shopping for large data sets compared to, say, retail scale shopping?
This is your
universal. Doesn't matter what kind of data.
Doesn't matter what kind.
Yeah, I think universal. I'm sorry. Yeah, I think yeah. I personally consider that, but I'm not sure because say like I mentioned earlier, when I studied the hurricane, I need a precipitation, but precipitation alone, so many data has precipitation there, and so many has the temperature there, right? So even we archive the air's data, we OMI data, whatever. So many different data products over there. So now we try to give the playlist. We give them all them there. You choose yourself. So but same time I also try to say, can we provide them some advice? But that's not the job for the salesman. So it's for the product.
Well, I think too there are two different types of users. You know, there's you know, like in the atmospheric chemistry community, for example, you know, they know about all the missions, they know about all the field campaigns that are going out, so they don't have to shop around. They know exactly what they're going to look for. I think it's when, you know, people who aren't familiar with what data sets are out there, you know, like local kind of government organizations or even some local companies that need to find these things, I think they probably have more trouble than any other type of user trying to navigate, you know, different data discovery mechanisms. So I think, you know, it's kind of a two-pronged approach. You got to make, you know, for the user that knows exactly what they want, you have to kind of, you know, make it easily accessible to them, so there aren't many hurdles. But, you know, for the folks that don't know what they're after, you have to make it, you know, kind of searchable and give them some information about what's out there.
Also, actually, I can make further.
I just was thinking about analogies, and I think, did you just ask, is this like a online shopping experience did you just ask that? And I think you just said yes. And I think I might have to disagree with that a little bit because, and I'm just thinking, I'm not usually one of those people that think out loud. So bear with me here. I think it's very different, actually. Think about, when do we order a whole bunch of the same thing? You know, usually when we go shopping, we're looking for a specific item that serves a specific purpose. If we go to Amazon online, we usually buy one book or one kitchen appliance or one gift for somebody. When we're looking online for data and digital data, we're not looking always just for one item. We're looking for a whole bunch of similar items or things that we can bring together that aren't marketed at the same place at the same time and in the same way. I think it's a very different use case. And I think maybe it's closer to the warehouse supply chain use case, maybe, which is a little, because you go online and you say, well, I think I found I'm not a business person. Disclaimer. But let's just pretend, which I like to pretend, I have an Etsy shop and I need to get something that packages up my little thing that I made and send it out to millions of users. I need to find the best deal for those little packages or something. And then I need to have a little card to go with it, and that goes to somebody else. And usually I think I just have to call them. Oh, do you have a package this size? I think that's where that large scale distribution, I think there's still the need for that human connection and deal making, for lack of better words. So I don't know, just thinking about this out loud.
You were stacked next.
Yeah. Actually, it might take us back a level. I was wondering if you guys, so I pulled up your Bitly and we keep talking about large scale, but I've heard different interpretations of the data that we're talking about. Is it large in volume? Is it large in complexity? Is it large in the number of missions that you're trying to harmonize together? So I was just curious how, and I see in your survey thing here that you're asking investigators what large scale means to them. But what are you all thinking large scale means as you approach this working group?
So, I think it's part of the journey. I mean, in general, what's big data? Big for me, right? And it could be velocity, it could be variety, it could be volume. And I think that is circumstantial. I think in the context of NASA and the working group, I would say something where because of scale or capacity, you feel that you run into more difficulties than that you're past the knee of some difficulty curve. Right, part of it is to find out. I didn't know if I was going to run into 10 guys with 3.4 petabyte data sets struggling to deliver them to a cloud or what when we started this. There was this idea that is just not well handled by the current system, and it's a consequence of volume or capacity.
So your large scale start with the volume, right? And then could be applied with the other.
Yeah, I mean, so Chris Linz has a group
3
about
week, 5 week, 4 week, 6 week.
Yeah, Chris Linz has another working group that's about functionality. So, for example, authentication and authorization's not part of my scope, but no one defined what it was. Chris defines it as pain due to scale, pain due to variety, pain due to velocity. And I think that's, I have a ton of notes here that if I go sit down and don't go attend the next thing, I'll write it all out and try to figure out what that means. So in practice, what I wanted to do with the group is to come up to about now and gather input about what that was, and then try to synthesize saying, is there something we can do by finding examples in other domains or not? You're all invited to the working group and to follow it, by the way. I should have put the link up.
Have you sent this survey out to investigators?
So we were encouraged to survey the measures people, and a simpler survey was sent out with mail asking twice. Of course, PIs are very busy and the response is very spotty. So then I took my student and she looked at the survey with Larry and modified it a bit. And at the moment, what we're doing is we're walking through Illinois earth scientists to try to build some kind of data set, NASA funded or not, using NASA data or not, just earth science. And I said, so I actually have a Word document where the survey is half completed with these questions. So I thought I would put them here and see if anybody else wanted to try. We don't have an analogous survey, and so I apologize for that, for data providers. And I wish we had that. We've had one discussion where one DAC talked about their issues. And I would like to work on that dimension, but.
So I believe you only submit to the measures most recent 2018, right?
Correct. Ben,
probably you need to submit to the old one. I'm more free time. Okay?
So Ben can tell you a story about going to the website, finding the measures grants, and then showing it to Larry, saying most of these guys are retired.
I'm the first generation here, measure 2006. Right?
So we'd be very happy to send you our survey, and I have your name.
So I'm going to put Steve on the spot and see, are there any questions that you think we should be asking or things that we should be looking at with as in terms of this working group?
No, I mean, I think yes and no. Like through the history of the working groups, these are some of the issues that have like been percolating around in the background. I think this is good to try and surface this. I think some people may have come here hoping for sort of some great answers, and I'm not sure that we have the answers, but you know, I think exploring the issues is important. I've just got I'm kind of made some random kind of notes, which are not necessarily things I think for this group to solve, but some of the issues that I've maybe thought about before, but sort of were touched upon in this. You know, one is the sort of the egress charges that Amanda was referring to, which I don't think we've kind of solved. That's going to hit us. Yeah, I think the answer is going to have to be the person who downloads it is going to have to pay the egress charges, but we.
Then somebody has the job of describing that as free and open, right?
Right, yeah. Right, and but that has all sorts of complications. Yeah, it's kind of mess. There isn't an easy way because that kind of ties into the other thing I think is as we go on with this, there's going to, and more things are in the cloud and easily accessible, there's going to be more automated access to these things, which you know could end up just rapidly multiplying the amount of stuff that gets downloaded. So some of the things I've seen here and in OGC, you know, people are looking at things like, oh well, how do we you know get our GIS system to just sort of you know talk seamlessly to NASA data or whatever data in the background, just download the stuff they want, and the user doesn't have to know about it and request it. It'll just happen automatically. Hey, you get a few million, you know, ArcGIS users, you know, randomly looking around and browsing for stuff, and all of a sudden your, you know, back-end Amazon Web Services being hit with all of these download requests that people don't even know that are being made. So, you know, that'll be interesting. And then, you know, we talked about moving data into the cloud, but that's fine. But then there are going to be other clouds, and we're going to want to move from this cloud to that cloud and to that cloud, and
well, and on-prem too.
Right. So, you know, that's complicated as well. I'm just giving more problems and sort of.
Yeah.
But this was kind of prompted by what was discovered there. The other thing is that it's just on file size and file formats. You know, I just have this ongoing thing in the back of my head that all of our file formats and things were really designed as archive formats, and we're trying to use them for something different. Yeah. And that's kind of part of the problem. So, you know, we were talking about, you know, you were talking about sort of file sizes and things. You know, these sort of things were designed years ago when it was really to put them away on tape and preserve them. They weren't really designed for interactive processing. So,
all right, well, we've got 3 minutes left.
So there actually is a paper written by a guy who's a bit of a wheel in medical information systems. And he's talking, you know, it traverses this same space, and his paper comes to the conclusion that the data storage must be available in central, and it must be paid by fees fees paid that's bundled into the computing upon them. I can send you that. I can send you that paper. So he came to the a different conclusion after studying his field, and it's a very well written up and a well articulated paper from a different domain.
But yeah, it's definitely an issue.
So one of the ironies is that those of us writing on the Internet 2 contract, right, allegedly get a 15% discount. I'm sorry, 15% of the computing charges that we accrue would mitigate download charges. And the honest to truth is that at Illinois, that's the whole university, not an investigator. And the profile of usage of the universities is that they're so far away from hitting this threshold of being charged for egress. All kinds of things I don't want to repeat in a meeting are told to me. And so it is useful, I think, for NASA to go look at the spectrums of users. And if users if universities tend to have the same kind of agreement and it tends to be the same as we have, very substantial downloads could happen with no charge to anybody. Because if you do the trace route into into Virginia from like Illinois, we go up to Chicago, we hook up to Internet 2. Internet 2 dumps it right off at the doorstep to the transits it to AWS. And you would have to be very red-faced explaining why you have an egress charge when your subscribers have placed a router right at your doorstep, right? Now, I imagine a good lawyer and business person could tell us why that's a good thing for Amazon, but I don't think that any of us would believe it.
Well, thank you very much for your generous contributions to this. I'll put on the SCED, I think our email addresses are probably there, up in there for joining the mailing list if you want to join the conversation.
That was not our intent. It might have been NASA's intent. But part of our problem, part of our charge is to at least find solutions other people had.
Yeah, I'll kind of chip in there as in my
What is your
ESDSWG coordinator role?
So he's my godfather in this.
So yeah, ESDSWG is the NASA Earth Science Data Systems Working Groups, and it's really intended for. It definitely has a NASA focus, but it is also intended to include people who are working with NASA data. But ESDSWG has always collaborated closely with ESIP, and that's kind of one of the reasons for being here today, and why it sounds like this would be a good group to continue in some sort of partnership with ESIP, because the broader community also has an interest.
So yeah,
in
the question so my attitude was that Earth science is a domain,
right?
And if NASA isn't in this today, it'd probably be in these kind of problems tomorrow.
So I guess there's sort of two answers there. One is, strictly speaking, ESDSWG and the recommendations that come out of the working group are primarily addressed at NASA,
yes,
and what NASA should do. But NASA is also interested in how it interacts with the broader Earth science community.
Recommendations to NASA can include considerations from non-NASA efforts that are in the same domain.
Yeah.
To say it.
Yeah.
Lawyer-like.
That kind of works.
Okay.
Actually, we have mentioned the data list. We try to see in the future probably be the cross stack. Then even us NASA even.
Right, because the problems are domain problems, and then NASA needs recommendations how to address it. It's not large. I could use some feedback about how to run it better and engage in a more flexible way. So thank you, everybody. This was, I've got 5 pages of enlightenment here that I have to somehow turn into a note.